Here I've just prepared a few material samples to try and explain what's going on with our materials in a way that we can see and feel, and maybe it's a bit more fun. So we'll start with some toast. I see it looks like we're making breakfast here, but I didn't intend it that way, but it just kind of ended up that way. So here we have, this is some bread printed in PPS-CF. This is the same material that the bell is made of, and it's has a heat deflection temperature of 252. So if we put it in the toaster along with a regular piece of toast, we'll set it to setting 3. We can start making some 3D printed toast there. So while that's toasting, in the meantime, we've got some water boiling here. Inside the water we have a 3D printed fin from a wakeboard. And as I mentioned before, there is a way to lock the dry state and the wet state properties. So in the boiler here, I'm boiling a fin, which is moisture conditioning it. And then this was a fin, I printed them at the same time, on the same profile. This one was just sprayed with a transparent high gloss lacquer. So the lacquer itself is just sealing the surface and making sure that no moisture can get in. So we feel this one is very stiff. And if we take the moisture conditioned one, you should be able to see that you get a lot more flexibility. Sorry, a lot more flexibility in the fin compared to this stiff one. I'd like to pass that around so you can get a feel for yourself. I think you really need to feel it to understand the difference. So same material, same printing conditions. Just one has been moisture conditioned, and then you can really understand what the moisture is doing to the material. So if we have a look here at our toaster, we have a laser infrared thermometer here. If we point inside the toaster, we can see peak temperature of 200 degrees, over 200 degrees. And we see that the PPS bread still not melting. I think if we made this with PLA, I think that it would be a big mess in there. Here we have a multimeter where we can test our ESD materials. This is a battery connector for a battery pack for the same electronic wakeboard, actually. So this is one of our customers. He's creating these electric wakeboards, and he has his own custom-built battery pack, and he needs ESD materials to make his, oh, the toast is ready. So you see, I think it's not really toasted enough, so we'll pop it in again. So we can do a quick test here, just to see if we get a reading of resistance across the material. And as we can see here, we're getting a measure of resistance across the material, showing that we have some ESD capabilities in this part. I'm going to just turn the boiler off now. So next we have a series of levers here. So this is printed with a strength profile. All these levers are the same. The only thing different is the material that's printed with them. So this red one is a PLA. This one, the white one, is a PTG. Actually, our Polymax PTG. Then we have a so this is Polymax PLA, then we have a PC1 and a PC ABS. And if we think back to our app where we have our materials, we saw at the top in impact resistance, we saw actually the Polymax PLA is top, then PC ABS, and then down to sort of at the lower end would be our regular PLA materials. So if I set this apple on here and then drop a bag of flour from a height, the apple goes up, right? But if we put a bag of flour on here and drop the apple, it's also going up. maybe I need a better tool. What do I have here? Hammer. And the PLA is broken, right? So if we try that with a better material, let's say, I hope this works. So we see the difference in tensile strength and impact resistance from the PC ABS to the PLA in being able to not only transfer the impact but also the tensile strength along the layers. So I think our toast is almost done here. Let's see, how do we cancel that? So see, toast, nicely toasted here, and our PPS bread, hot to touch but still not deforming. You can see no flexibility there. So that's a demonstration for our bread. We can put some butter on there as well, because we always need butter with our toast. You can hear it sizzling away here, so you can see the butter is sizzling on the surface. Okay, and then so now we have two parts. This is our PC and this is our PCFR. So the idea was to set them on fire. So this is our PC part. So you see there is a flame on the corner, and it will continue to burn. Let's just pop that in the water. Now PCFR, it should also burn, but it should self-extinguish. So you see a flame now, and now it's gone out. So again, with our ESD material, we also have a support material, which is this green material here, and it's printed with just as an interface layer. So it's actually very efficient when we have this material, because you only need to use a very small amount, and then you use the main modeling material as the bulk of the support. So I just want to show you how easy it is to remove, by hand. A part like this, you get a very nice surface finish. You can just remove your parts by hand. You have a really nice flat finish here. We also color the material green, so it's very easy to see. If you have any left over, you can just flick it away by hand. So it's a breakaway support, and the interface is designed for long chain nylons. It's also working with PET materials. So then finally, I've made some ninja stars. If you'd like to throw one at this pair of melons here, you'll notice these two melons. Hopefully we can get them to stick in. I better come round the other way. I missed, but it did pierce the flower. Yeah, so I guess we probably shouldn't play too much with these, but if you'd like to take one just to get a feeling for the material, you can take one here. They have that same metallic quality and very sharp. Yeah, so I think that's the end of our breakout session. Hopefully you got a little bit of a feeling for the materials.